We're really innovating on content today. Welcome to this new series called Software Engineer Reacts. The name is pretty self-explanatory. In this series, I'm going to look at some articles, videos, tutorials, really whatever related to software development, and giving my thoughts and analysis on it. Recently, I ran into this roadmap by roadmap.sh. It's about software design and architecture, which I am really passionate about. I think this is my strong suit. So we're going to take a look at this roadmap, and it looks like it references Khalil Stemler's software design and architecture map, which I know a little about. I've seen it a couple times, so I might be a little familiar with this roadmap, but I've definitely not gone in depth into this. So this is going to be kind of a first time reaction. So it looks like they have a mini map of topics here. Let's take a look. Starts with clean code, of course. Programming paradigms. So I'm assuming the different kinds of object-oriented, functional, structured, things like that. Oh, it's right there. Okay. I did not read that. Object-oriented programming. Okay. I don't see functional programming in here. Looks like there's a dedicated section to object-oriented programming, but not to functional programming or structured programming, which is interesting. Design principles and design patterns. All right. Architectural principles, architectural styles, and then architectural patterns. Okay. So I think it's going to be interesting looking at what the difference would be between these three, and the same here between these two. And then finally, enterprise patterns. All right. So off to an okay start. I'm going to first go through this and try to explain very quickly what each of these things are before I give my thoughts on this. So let's go to clean code principles. Be consistent, meaningful names, okay, indentation code style, keep things small, pure functions, cyclomatic complexity. So in case, I'm pretty sure cyclomatic complexity is the complexity of a function or a code in terms of conditionals and loops, or I think we can also call it branches. So instead of like flowing in a single line, how many different branches there are to a function, and that's called the cyclomatic complexity. It's a good thing to minimize it, sure. Avoid passing nulls and booleans. Okay. Keep framework code distant. All right. Correct constructs. Tests should be fast and independent. Meaningful names. Oh, I think there's a repetition over here. Organize code by the actor it belongs to. I think the word actor can have some different definitions, so some clarification would have been helpful. Command query separation. Okay. Command query separation, in case you don't know, is a pretty simple concept where a function should either change some data or return some data. It should not do both. It helps with a bit of mental model while writing code. Keep it simple and refactor often. Okay. So yeah, I think these can pretty much be found in any of Uncle Bob Martin's book or talk or anything like that. So yeah, I agree with pretty much everything here. Let's move on to programming paradigms. Structured, functional, object-oriented. Okay, your classic. And then object-oriented programming. Okay, so looks like it's split into three different things. We have model-driven design, we have paradigm features, and we have primary principles. So let's start here. Inheritance, polymorphism, abstraction, encapsulation. Okay. Pretty straightforward beginner OOP stuff. Then we have paradigm features, so abstract classes, which are and interfaces. Okay, so these two are pretty similar. The slight difference is that in abstract classes, you can build in some values and some behavior, whereas interfaces are just pure signatures. They cannot have any behavior or data in them. Concrete classes, which is just the opposite of abstract classes. Finally, model-driven design. Okay, so we have domain models, anemic models, layered architectures, domain language, and class invariants. Cool. So this is the thing that I am very passionate about. I love model-driven design. Being able to build domain models which are rich and encapsulate data and behavior nicely, that is a very good thing to have when you're writing software. So yeah, that's basically what a domain model is. It's modeling concepts in real world into classes that couple the behavior to the functionality. To build rich domain models, you kind of have to combine data and functionality together. Anemic domain models is the exact opposite, where you have a model that just has data without any behavior in it. So you have a data model that you can just change certain properties of it as you want without limitations. It's kind of an anti-pattern. Layered architecture is when you layer your code by technical concerns. Domain language is pretty important. I feel like a lot of this is just domain-driven design, but put into object-oriented programming. Finally, we have class invariants, which class invariants are classes that are they're similar to domain models, but the word invariant here means that it can never be in an invalid state. So, for example, the class will have some private data in it that you cannot just change by reassigning or a setter. You'll have to call certain methods on that class, which will check the input that you have and always update all the data together so that it's always in a valid state. Okay, so model-driven design is the most complex part here, and even if you are not an object-oriented programmer, I think a lot of these principles should still be able to help you quite a bit. But I'll save more of my thoughts for later. Let's move on to design principles because we don't have dedicated sections for any other paradigms here. So we have composition over inheritance, encapsulate what varies, program against abstractions, Hollywood principle, solid, dry, and Yagni. Okay, so let's see. Composition over inheritance means that just don't use inheritance in object-oriented programming. Composition is a better way to approach reusable code instead of inheritance. I don't think anyone would disagree with this. It is a pretty widely accepted wisdom that composition over inheritance is good. Encapsulate what varies, that's just pretty straightforward encapsulation. Program against abstractions. I just noticed there's a typo there, but I believe what this really means is just try to create abstractions, or I'm not sure. A Hollywood principle, if I remember correctly, is don't call us, we will call you. And then solid, dry, Yagni. Solid originated from object-oriented programming, but still pretty helpful again, regardless of what kind of paradigm you're writing code in. Dry is just don't repeat yourself. Yagni, you ain't gonna need it. Cool. So design patterns, they just have Gang of Four and PASA. I'm not sure what PASA is. Let me quickly look it up. PASA design patterns. Okay, so it's just pattern-oriented software architecture. So pretty straightforward, nothing there. Never mind Amazon, I don't want to buy any books right now. So they are not, looks like they're not going to list individual design patterns here, which is fine. There are way too many design patterns to list in this roadmap, so it's okay to just point to some pretty nice resources here. But okay, so I see the difference between patterns and principles. Patterns would be specific patterns like the observer pattern, adapter pattern, strategy pattern, which are kind of designed to solve specific problems. Or these patterns emerge when you're trying to solve specific problems, and these principles are the kind of principles or guidelines that the patterns will follow. So you can think of it as, you can think of design principles as ingredients for a recipe, and then the patterns itself would be the recipe. All right, let's move on to architectural principles, styles, and patterns. I think this would be a similar pattern, for lack of a better word, where the principles would be the raw ingredients, and then the patterns would be like the final product or the final recipe, and then styles would be something intermediate, I guess. Okay, let's look at architectural principles. We have component principles, policy versus detail, coupling and cohesion, boundaries. Okay, I believe component principles might just be that you should break down your application into smaller components and compose it out of those components. Not sure what policy versus detail is. Let me see if I look it up, what happens. Okay, so I got this result. Of course, there's an Uncle Bob article with this. Let's take a look at that. Does this say policy? It does not. Okay. Policy is mostly concerned with business logic. Detail is when we specify how the policy happens. Okay, got it. So policy versus detail is an abstraction concept where you should specify what is happening instead of how is happening, or implementation detail versus signature. So for example, you can have a function that's called create user, and it handles the implementation detail of creating a user. But if you have, if that function is called create user in SQL database, now to call this function, you need to know that there's a SQL database. So there's an element of detail there, whereas create user is just a policy where this function does the job of creating a user. Coupling and cohesion and boundaries. These two, I think, or technically these three, are I think really important and kind of underrated concepts in software architecture. I will most likely create dedicated videos on coupling and cohesion and also on boundaries. But in a nutshell, coupling is how much two elements or two modules are dependent on each other, or like if one changes, the second one also has to change. Cohesion is how those two elements are close to each other in functionality. So for example, creating a user and updating a user are pretty cohesive because they have pretty similar functionality. However, creating a user or placing an order are not really cohesive. They're two separate things. And boundaries is pretty similar. It just combines the two concepts where it says that things should have a high cohesion and low coupling. But yeah, I'm almost definitely going to make dedicated videos about these, so subscribe down below. Alright, let's move on to architectural styles, which is the intermediate between principles and patterns. We have messaging and distributed, okay? And we have event-driven, pub/sub. Here we have client-server and peer-to-peer. Okay. Messaging is used to decouple parts of application, which again, coming back here, coupling and cohesion. A great way to decouple two elements or two services is to just implement messaging between them. A pub/sub is useful when a lot of different services have to react to a specific event. And event-driven, they're kind of the same thing, but event-driven, I believe, also includes putting the message in a persistent queue somewhere. And down here, distributed, once again, it's when you distribute your process into multiple distributed or smaller pieces that are in different machines running separately. And we also have structural here, which is once again component-based, monolithic, and layered. So component-based would be something like microservices, where you break your application into individual independent components. Monolithic is the opposite, where everything is just into one bundle. And layered, it would be when you layer it by technical concern. So let's move on to architectural patterns. We have service-oriented architecture here, which is a little dated, I think, now. I don't think anyone should be building with the service-oriented architecture pattern anymore. Enterprise service buses is the first thing that should come to your mind if you know what SOA is. If not, don't look it up. Or look it up if you just want to learn how we used to do software. CQRS is Command Query Responsibility Segregation, which is one of my favorites. So if you scroll up here, we just ran into command query separation, which meant that a function should either return data or modify data. I believe CQRS is just taking that concept, but to an application or to a service level, where let's imagine you're building a web server with API endpoints. So those API endpoints should either only return data, in which case it's a query, or they should only modify data, in which case it's a command. CQRS is also something that's heavily misunderstood in the industry, and a lot of people think it's way too complicated than it has to be. For example, a lot of people will argue that CQRS means you also need to have two different databases, where one would be for the read model, one would be for the write model, but that's not really a necessity. It's something that you can do. I see event sourcing is here. So if you kind of combine event sourcing and CQRS, you would need those two different databases, but that's not a requirement for either of these. Domain-driven design, of course. If you're a software developer you are serious about this field, you should really learn domain-driven design and what it is. I am planning a video series about domain-driven design that will come up on this channel soon. So once again, subscribe. All right, model view controller. I think I have a love-hate relationship with model view controller. I don't think I need to explain what model view controller is. I think most people already know it. My personal opinion is that model view controller is too complicated for simple projects, and it's too simple for complicated projects. Speaking of complicated, we have microservices here, which I already have 3 videos about, so go and watch them. Blackboard pattern, I'm not sure what that is. Let me look this up. Blackboard pattern. Sure. Blackboard pattern of autonomous and navigation. Looks like there's a Wikipedia article about it. Let's see if Wikipedia has any help. Computational framework for the design implementation system, specialized modules, complex non-deterministic control strategies. Okay, that does not help at all. Anything else? Auto navigation. Looks like there's a lot of autonomous navigation around Blackboard pattern. Okay, I will look this up later, and I would encourage you to also look it up. It might be something interesting. Microkernel is the pattern. It's also it's more widely known as plugin architecture or plugin pattern, where you have a core piece of software and it exposes some APIs in a way that you can build plugins around it. So any code editor or web browser will have plugins around it, and that's the microkernel architecture. Serverless architecture. So I believe what they mean here is FaaS architecture or functions as a service. I don't agree with putting serverless here, because serverless is a lot much more than just functions as a service. Whenever you have any kind of a backend service that you are not thinking about the servers for it, you're just thinking about the service in general, it is serverless. So something like PlanetScale to host your databases, or something like Auth0 for your authentication, these are serverless architectures because you don't have to think about physical servers. So if we imagine that this is FaaS architecture, yes, that is also a valid architectural pattern, and yeah, it is very different from a lot of these. Message queues and streams, definitely. If you're building any kind, like I mentioned earlier, if you're building any kind of software at scale, you need to know about message queues and streams. They are incredibly helpful in decoupling applications and just making your workflow faster. And finally, we have event sourcing, which I'm probably also going to do a video on. The event sourcing pattern really flips a big paradigm in our head. Basically, what event sourcing means is that every time there is an action or something happens within your system, you create an event and you store the event. So for example, if I change my address, the system doesn't go into the database and changes the address field on my record. The system just stores an event that says Dev Agarwal changed his address from A to B. That's it. That's what event sourcing is. It has a lot of trade-offs. It's simple to understand and it has a lot of benefits, but it's also a little complicated to implement. For example, if you have a stream of these events stored, every time you need to know the current state, you have to replay the events from the beginning to get to the current state. It's helpful in the sense that you can just throw your current state away and rebuild it at any point. The disadvantage there is that you have to build your current state. So yeah, it's a very interesting concept. I will almost definitely make a video on that too. So that's all of the architectural patterns. Let's go to enterprise patterns. So we have DTOs or data transfer objects, identity maps, use cases, repositories, mappers, transaction script, commands and queries, okay, value objects, domain models, entities, and ORMs. Okay. I'm not sure why or how these are considered enterprise patterns, or I'm not even sure why this is a separate concept. Like, a lot of these can be put in a lot of these buckets. For example, value objects and domain models come straight out of domain-driven design. Repositories to a great extent as well. Commands, queries, once again, these are just from CQRS. All right, so I think that's pretty much it for this roadmap. Looks like it's connected to the backend developer roadmap, which I might look at in the next video. Let me know if you want that. Don't think of this roadmap as a roadmap. And what I mean by that is that you should absolutely not consider learning about this in this linear format, because a lot of these have really nothing to do with each other. For example, you don't need to write the cleanest code to be able to build microservices. A lot of this you can learn independently. The only thing that are kind of dependent on each other would be things like design patterns and design principles, and the three of these. But even those, you don't have to learn the principles first and then the patterns second. Instead, what I would recommend is quite the opposite, where you first learn the pattern and then you try to learn how that pattern solves a problem while achieving these design principles. And then I already expressed my thoughts on the enterprise patterns. I don't think this needs to be a whole separate topic on this roadmap. A lot of these are part of the other concepts here, like I mentioned before. Object-oriented programming, I like that it's here, because a lot of these concepts are really important to know, even if you don't write in Java or if you don't write classes. So yeah, that was a roadmap. My final thoughts on it are, treat it as more of an exhaustive list of things that you should look out for and things that you should potentially learn if you're serious about getting into software architecture. Don't treat it as a roadmap, because it's not in a linear format where you have to learn the first step before getting into the second, and so on. You can start at any point from any concept if it sounds interesting to you, and then you can pick up anything else on this roadmap at any point. Software design and architecture is a huge umbrella, and there's a lot of things and concepts and patterns that can go under it. Like you just saw in this roadmap, it can feel really overwhelming at first. Let me know in the comments below what you think. If you don't know where to start, you can let me know. I can try to help you out with it. And of course, subscribe to the channel for more reaction videos. Let me know what else you would want me to react. A lot of these concepts I am going to make videos on soon. For example, CQRS, event sourcing, and domain-driven design, which would be coming up next.